Well, welcome to this second community call inside in June. It's wonderful to have you here. One thing I want to do is a little bit of announcement for all our community calls going forward is that we've decided that we will have all these community calls held at 10 o'clock Pacific time in the future. And we will no longer be having them at the 7:30 time, which in the evening, which was kind of more focused on the Asia time zone. We're actually breaking them up into two sorts of community calls. So going forward, all these community calls will be at the single time every 2 weeks. And we have a great agenda packed up for you here today. We have Eddie coming in from Vonage to talk about his work with Dapr there. We'll have Alessandro touching on one of the features that comes in the V1.8 release that's being built now. You'll have seen release candidates out for it and be available, as release in the next coming weeks. Paul will dive into the new set of quick starts for bindings. You'll have seen, if you've gone through all of our other quick starts, we have them for secrets, for service invocation, for pub sub, and we just released a comprehensive set for bindings of how to demo and use them. Then we'll have Nick talk about the extension, AKS extension for Dapr, and then if we have some time at the end, we'll have some open discussion. So with that, I will hand over to you, Eddie, and let you share your screen and take it away.
All right, thank you, Mark. Let's see here. Everybody see my screen okay?
Yes.
All right, perfect. All right, well, thank you once again for the opportunity to come up and talk a little bit about our journey with Dapr and our experience using it at Vonage. Really quick, to give a kind of an overview of what is Vonage. A lot of folks may have heard the term, they may have heard mostly around our voice over IP, which kind of started the company over 20 years ago, but we've really evolved in the last 20 years and grown into many different parts of the industry. We cover quite a few things. And so we're headquartered in New Jersey. We have offices all across the US, Europe, Asia. We have remote employees. I'm one of those. I'm based out of Dallas, Texas. We have over 2,000 employees. We offer an API and a developer portal. We have over 1 million registered developers on our platform. And I'll talk a little bit about what these developers can do on our platform. But we're very, very much into the innovation space. We do a lot of patents. We connect minutes, both SMS, voice, video, WhatsApp, Viber, and we serve hundreds of thousands of businesses across the world. With something like that, that really puts us in a unique situation where we are sometimes the lifeblood of a company or a critical connection point for a business. And so we have to have our systems deployed all around the world. And we connect 1,600 telecommunication providers to each other in almost about 100 countries. We have to be secure, highly redundant, highly reliable. We also integrate with many different providers with all different kinds of languages, whether that's the latest and greatest, the whatever's trending out there, or some legacy stacks sometimes that 20, 30 years old. And we try to do that all in a very simple and scalable way. So that presents in and of itself a very, very big technical hurdle. And my role at Vonage is to look at how our architecture adapts to this and how we can plan and be ready for the future. Basically, the 4 pillars that we have in our architecture revolve around communication APIs, unified communications or UC, contact centers or CC, and conversational commerce. Really, the communication APIs that developers use are voice, video, SMS, verification, and that could be for MFA, for 2FA, for step-up authentication. You could do it on any one of these channels, and these are really the building blocks of the Vonage stack. And so these are around the world. They're the same piece of code will probably be deployed in multiple countries to get us to that resiliency number that we need. And same with SMS, same with video, same with voice. These are all things that are connecting to external parties. And one of the challenges that we have is how do we detect them? How do we retry whenever there's a failure? How do we discover these connections? How do we make it all within our SLA for these real-time communications to happen without really being affected by whatever's going on in whatever cloud or other network issues that are happening. On top of that, we build our unified communications. This is, think of it as your video platform, your office phone, your full solution online in lieu of the traditional phone and email system. This is built on top of our APIs. This gives us kind of a view of what you can do with our APIs. And again, very similar. This needs to connect with an actual telephone provider. It also needs to connect with your traditional SMS providers. It also can do WhatsApp. It could do LinkedIn, Viber. So there's quite a lot of things coming together. And I think I'm hopefully trying to paint a picture of the complexity and interconnectivity that we have, and painting a picture to where Dapr can fit in here pretty soon. We also offer contact centers. Contact centers are when you dial in and you've got a problem and somebody picks up, either that's a robot or a bot via IVR or an actual person. But the big thing about contact centers is we need to go pull that information from many call, whether that is typed, spoken, or via email, actually knows what you're talking about. So again, that's where it fans out from one connection to multiple integrations, and all of that has to come in a very secure and timely fashion. We also offer something new called conversational commerce, which is, think of it as when you see an ad on any of your favorite social platforms or anywhere online, and you like that product, usually you click and you end up to a site and you go to either a cart or you go to a contact us now or some other kind of drop. But what we've done is we've been able to leverage all of the things that I've mentioned before, plus adding a bunch of AI on top where you can purchase from within the ad. This is a new thing that we've added. So that throws in the mix a lot of the compliance, payment card information, personal information, finance information on top of what is traditionally, maybe not the most secure thing, a banner ad, but now we've got to elevate that, secure it, and make it in a timely fashion, and then hook that into a workflow and integrate with the rest of the system so that when you do call in, if you want to escalate or if you want to reorder, if you want to cancel, these are all things that get tied together. So with all that, we looked at Dapr really as a way to fit into our architecture, both our current and our future architecture, and solve a lot of the things that have traditionally taken a lot of time to do. I want to say that one of the benefits of Dapr is that it brings a lot of already built high quality building blocks that you can add to both new and existing systems. And I'll highlight a few of the places that we use them. We don't use everything. We are looking to expand it. We're always looking to experiment with some of the new things. I know Actors is coming on pretty quick here. But these are primarily the 6 things that we use at Vonage, and Dapr helps us in quite a bit. Primarily service invocation is one of the main things that we use, and not only, I would say, for new code, but I would say in the majority of our use cases, our legacy code is benefiting tremendously from service invocation. It gives us the service discovery, both within clusters and across clusters. It automatically adds retry logic, which is phenomenal. We can consistently build the retry logic across all of our applications declaratively without having to go and ask developers to re-implement their code. The benefit of doing that, obviously, is being able to quickly, without disruption, upgrade things like adding MTLS, adding access control, adding tracing. This has been huge, being able to almost overnight add distributed tracing to a lot of our service invocation, where previously it wasn't there. And the things that we've had to change have been mostly configuration. So we would annotate the deployment and then change the variable that said connect to this service to now connect to your Dapr sidecar. And just a simple change like that, almost like, lit up a dark room that showed all the interconnectivity that we have, identified lots of bottlenecks, and really was a huge benefit for us at Vonage. We also leaned in a lot on the pub sub components. A great thing about pub sub is it simplifies it. Not all languages are built the same, and not all of them have the same quality of integration with some of these systems. So being able to consistently, in a decoupled manner, point to a Kafka or an Azure or Google Pub Sub or a RabbitMQ without having to change the code, and being able to do that declaratively was huge for us, because I'm sure we're not the only ones, and in my career, I'm not the only one that had a problem understanding what talked to what. And we looked at investing into a CMDB, but having the declarative binding of what's talking to what topic and what's publishing to what topic was huge. We were able to go into our source repository and effectively build a service map on asynchronous communication, which previously you hoped either the developer had documented it, or you could you invested in a tech that gave you some kind of insights to that. So that was great. The self-documenting feature, and you'll see this is common, the declarative binding and self-documenting across all of the components that we use at Dapr are really helping us out build a better picture. They're helping us figure out where bottlenecks are, where optimizations are, and ultimately helping us save some money when things come down to it. It's the same with the bindings. Being able to connect to third parties easily in a kind of a standard way. And we do use mostly the HTTP binding there, because it is the easiest one to implement in pretty much every language. Even in Bash, you can write a script to talk to the Dapr sidecar, and now you're talking to Twitter without having to do any kind of implementation. So that's been huge. And again, we can go and look and see what's the impact of changing this binding. I can go look at tens of thousands of repositories and figure out, okay, we've got a couple of hundred of these bound to this endpoint. That's going to be the scope of the change in the blast radius. Again, I'm repeating a lot of this, but really the great thing about the way Dapr was built is it is opinionated, but that opinionated nature helps with consistency and speed. And so again, it simplifies configuration. Now you don't have to include the drivers for one NoSQL database versus another. You literally implement it. You use the sidecar, and you're talking gRPC to the sidecar, and you're ready to go. We've seen a lot of benefits here with cost management, because I can implement let's say a local instance of my state database for development and for QA. And then when I get to higher environments, I can now scale that to maybe a cloud provider, and know that it's not my code doesn't need to change. And what I've tested, my immutable deployment is the same across all environments. And really it's just the performance benefits I'm going to get from the underlying tech. Previously, you had to have feature flags. In my experience, whenever you are under a deadline, the first thing to go are all these fancy feature flags. And so using the state management components is great, because we could very easily add that across the board and actually save time to add more features. So it really helped us in our core versus context decision making, where we didn't feel that state management was part of our core offering. It was more contextual, and Dapr filled that gap really, really well. I talked about observability. Being able to turn on distributed tracing has been huge. You can imagine a company our size. We leverage quite a few different observability platforms. The great thing about using a standard is that you can hook it into any one of those, and you can look at it in any of the commercial providers or any of the open source providers and see the same distributed trace, which was great. Again, very much on the cost savings, but also very good on the M&A path. When someone comes in, we can continue to keep the workflow going without breaking all of that and breaking the support cycle. So that's been a very, very beneficial for us as well. Finally, components. I think this has been the one that I've been the most passionate about, and I think this is how I got on this team's radar. But we love the Dapr components, being able to inject things, from our own perspective to our developers. So I run architecture at Vonage, and sometimes we want to specify policy across the board, and we can do that now using a Rego script. And so we can declaratively apply a Rego script to any number of Dapr components and manage that centrally. The great thing about all of this is that it really lets you adopt a GitOps practice, a true GitOps practice, where you can very quickly integrate, accelerate, and see the benefits at an enterprise level. One of the things that we do is we are trying to make that delineation between core versus context and understand what is our core business, where should we be focusing all our efforts, and using tools where that's not our core, where it's our context. So through GitOps, we can declaratively deploy Dapr to any number of clusters, upgrade it in the same way. We can apply policy to all of those in case we ever need to apply a global policy. It's rare, but it's good to have that in your back pocket. The self-documenting feature of being able to look at these YAML manifests and build a map of that, and we do use other open source projects from CNCF that help us catalog and build a developer portal, all based on aggregating all this stuff. And then honestly, we've integrated quite a bit with Kubevela, which is an open application model, and we have traits for all of this. So it really fits like a glove into the whole open source, GitOps and DevOps, products. It lets us very quickly upgrade, experiment, and elevate all of our services. And we have, as I mentioned in the beginning, we have a need to have a lot of services in a lot of places synchronized and able to talk to each other very quickly. So I know it's quite a bit. And these are the end of my slides. I think we'll open up to any questions. If not, we can turn it over to the other presenters.
No, that was amazing and really insightful, Eddie. It was great to hear about your journey of using Dapr. Actually, one of the questions I have is, how many of your applications, you talked about brownfield versus greenfield, are the vast majority of your applications brownfield that you've integrated together, you've applied this to? Is that the case? And have most of those applications been moved onto a Kubernetes platform? How did that work?
Well, that's been a journey. So yes, I would say about, we're an established company. We have a lot of software that's already been either deployed in one mechanism or another, but I would say 80% of our stuff is brownfield to 20% is greenfield. And we've applied a lot of different technologies. We use cloud native build packs, which is another CNCF project. I mentioned Kubevela to simplify the deployments. We use Dapr to simplify a lot of these communications and the building blocks. We're very quickly I hate to use the term lift and shift, but we try to take a lot of our legacy things put them into Kubernetes and deploy them out there using a lot of these tools. And that is only a temporary thing until we have the opportunity to either rewrite them or there's a new neat use case where we can write something else. But at this point, I would say about 80-20. And of those 80%, we're probably at a 50-50 using Dapr.
All right, that's pretty good. Let's open up for any other questions. One that Nick posts is that, do you know about the resiliency policies? You talked about the clarity, putting resiliency on the service invocation. So are you using the resiliency policies at the moment?
At the moment, we're only using the basic resiliency. To be honest, one of the biggest pressure relievers that Dapr gave us was just the service invocation, service discovery. We use I think there's a default retry and round robin. And I know there's some new resiliency stuff, but we haven't put that in yet.
Right. Okay. That's something to kind of worth looking at. That was put into the 1.7 release, and we've improved it in the upcoming 1.8 release.
Yeah, we always run about a version behind. We are in our lower environments on 1.7 now, but in most of everything else is 1.6.
So Vedran asks, can you say some more details about Kubevela and the self-documenting side of those things? You know, what does it you mean by the self-documenting side, and how does that, and talk a little bit more about Kubevela? Can you add some more clarity to that? Sure.
Kubevela implements the open application spec. It used to be a project called Rudder, R-U-D-R. I guess the last vowel was lost on Dapr and Rudder, but it's a simplified way to define sometimes very complicated Kubernetes manifests. And the idea behind it is to create it as a infrastructure agnostic manifest. So what we've done is when you define, this is my image, I want 2 instances of it, you can define a concept called the trait, which is just like a property. We have a trait called Dapr. And in that trait, you say, I would like service invocation on this port. I would like pub sub to Kafka and pull the secret from over here. And then, you know, in 20 lines of YAML, it'll generate, you know, several dozen, if you would, opinionated YAML files for the manifest that either the upstream project or, you know, my team and the DevOps team put together in our repos. So the thing about that is now we have all of this documented either in a raw YAML or in the OEM YAML in our source code repository. So by looking at these YAML files, they'll define that this service is tied to this topic on this underlying technology. And then, you know, from a secret, you look at the secret name, not necessarily the thing, and you know that this is, you know, let's say pub sub 1. You can then build a map. And the tool that we use is Backstage from Spotify, and it'll link those together. Just by looking at what's in source code, it'll now draw you a picture of who's publishing on what topic, on what underlying technology, and who's subscribing. All because you've declaratively bound your Dapr sidecar to your code. Now, this only works if you use it declaratively. You can do it programmatically, of course, but we've decided to go declaratively for that reason.
Yeah, that makes total sense. So the declarative nature of that and the bindings and the component specs allow you to hook that all together. Pretty good. We've got another question here. It says, given that Vonage manages many connections to third parties which exist beyond the cluster, are you making use of the Dapr HTTP binding to these third parties?
We are not for these third parties. We're mostly using it for our own service-to-service invocations. I can't say that for certain. We do offer it into our clusters, like Dapr is offered as a component in every cluster. So there may be a team doing it here or there, but across the board, it's not something that we've implemented.
Okay. Let's get any other questions that people would like to reach out. If you want to unmute yourself or just post it in the chat window, feel free to, you know, reach out to Eddie right now.
Yeah, I have a question. First of all, thanks, Eddie. This has been a really great overview of how Vonage is using Dapr. You mentioned cross-cluster communications. Can you elaborate a little bit more on how you're achieving cross-cluster with Dapr and what are other technologies you're using to implement that on the network level?
Yeah, we are looking at a couple of things. I know you and I have talked a little bit about this. So there is another open source project called Scupper that we are using for cross cluster communications. I'm looking to writing that blog post, so that you'll see that coming soon. But we also have a lot of cases where the clusters have network access between them, and Dapr can connect to another's ingress, which I guess would be similar to using the HTTP binding to the third party. But most of what we're using it for, like I mentioned, is using Scupper as that pipe, and then Dapr inside of that pipe to connect between clusters.
Okay, thank you.
And we did experiment with Submariner. We did not get as far as we'd like to, but that's something that we're going to bring up again later this year, hopefully, if we have some time.
And he also talks a lot about.
Hey, Eddie.
Howdy. Go ahead, Mark, and then.
No, you go ahead. Go ahead. Keep going.
Sure. Yeah, it was just a follow up. Yaron and Mark and I talk about the cross-cluster communication a lot, so this is super interesting. So you set up the pipe, and I'm just curious, do you have service discovery going with Dapr at that point, or do you rely more on kind of like your own name resolution using bindings?
Well,
does that question make sense? You
have to annotate the service, and so what we've done is we've annotated the Dapr services. And then and then any other services that need to be exposed are annotated as well. To be frank, people smarter than me on my team have set this up, so I'm going to get in the details and put them together. But that is my understanding of how it works.
Okay, there's another.
Sounds great. Yeah, I'd love to learn more.
Yeah.
And Oliver posts, and this actually goes on to a question, and probably we'll just do this and maybe one more. And he has a question I was also curious about, which is, given Vonage is using high concurrency, high frequency stuff, telco, etc., how are you monitoring throughput for your operational assurance, your SLAs? Are you using Dapr Observability for that stuff? So are you looking at your throughput and you're measuring your metrics and things like this?
Well, we have a lot of our edge infrastructure measuring that stuff for us. Obviously our SLAs matter at the edge, from when they call at the entry at the API gateway to exit of the API gateway. That's really what the end customer cares about. We're really measuring internally the point-to-point SLAs, and we're aggregating a lot of that stuff through our observability stack, our monitoring, logging, and alerting stacks as well. And what Dapr gave us is it gave us that additional open tracing kind of view into everything from an observability perspective. To be frank, that's not something that's readily implemented yet. And so being able to flip a switch and turn it on was huge. Usually you have to purchase a commercial product and have their agent do this for you to really try to see where things are. So that, with the log aggregation, with the Prometheus in this case, metrics, it added an additional dimension that kind of let us see under the covers, or see how the sausage is made.
And I very much liked as well that you talked about that you integrated with many existing of your monitoring solutions you already had. Yes, so sounds like you have more than one.
Of course, yeah. I mean, we have, throughout the years, if you follow Vonage, we've acquired several companies, and every company comes with their own tech stack. They were all successful companies in their own sense, and you can't just overnight cut all that stuff out. And so you need to continue to have that observability stack running, or you need to have that language that they're using implemented. And so that's where Dapr was very attractive to us, because it doesn't care. It's opinionated in some things, but it's not opinionated in what language you write your code in. It's not even opinionated in where you deploy your code. You can deploy it, self-hosted. You can deploy it in Kubernetes. You can deploy it in console and Nomad. I mean, that is one part where it kind of steps away and says, do what you need to do. And so because of that, we've adapted it, and we've been able to take like the open telemetry standard and feed that into several commercial products and get that in there as well.
Oh, that's fantastic. Well, thanks for sharing, Eddie. This is really, really good. Hear the story. I'd love to get you back sometime in the future when you've done even more, something like 6 months from now, and kind of share some more details. And
absolutely. Thank you all for the opportunity. Appreciate being here, and keep up the great work.
All right. Thank you. So with that, we are recording again. I will share my screen. And you should be able to see my screen.
Yep. Mm-hmm.
All right, so we're on to talking about the Sidecar injection watchdog. I'll hand it over to Alessandro to talk about this upcoming feature.
Yes, thank you, Mark. Can you go to the next slide, please? So this is a new feature that is coming in Dapr 1.8, and it's meant to improve reliability in your operations in some specific situations. So you know that Dapr runs as a sidecar. You have your pods contain your containers that have your applications, and then each pod gets the Dapr sidecar injected. We have noticed that in some situations, which are uncommon, but it can still happen, there can be some challenges there. So just a very quick recap, how does the sidecar injection work? So here you have your operator, the person on the left side, and then the Kubernetes cluster. Can you click, please, Mark? And the operator asks Kubernetes, can you please deploy this pod? And Kubernetes, before doing that, can you click, please? Sends a request to the Dapr Sidecar Injector, which is one of the services that are deployed on your Kubernetes cluster when you install Dapr. And inside the Sidecar Injector, there is one component, let's call it, called the admission webhook that gets requests from Kubernetes. Kubernetes asks, are you okay with this pod being deployed? And can you click, please? The Sidecar Injector responds, yes, you can deploy this pod or this deployment or whatever it is, but please add the Dapr Sidecar container. So what Kubernetes does, please click, is deploys then your pod that contains your app and a Dapr container. This is how things work behind the scene. Now, there is one thing here that can go wrong. You see that Kubernetes asks the Sidecar Injector, and the Sidecar Injector responds. But can you click, please? Last one. What happens if the Sidecar Injector fails? This is not very common in a fully operational cluster. Like we have seen that happening in some very specific situation, a little bit uncommon, that the injector never responds. But the most common scenario where you can find this is in case of, for example, a total cluster failure. We've had customers saying that they stop their entire Kubernetes cluster and then they bring it back. What happens is that in those situations, there's a sort of race condition. And if your applications restart before Dapr and the Sidecar injector are restarted, you might get pods that come up without the Dapr container. And this is bad because if your application is designed to work with Dapr, you need to have the Dapr sidecar or things can break. So for 1.8, we are introducing a new experimental feature in the Dapr operator service that should help addressing these problems. And I'm going to show you now a quick demo. So let me share my screen. This one. I'm going to show you a quick demo of how this works. So I'm going to simulate the situation where the cluster and then all pods are stopped, and then you bring the cluster back up. The pods are restarted in a random order. Now, I'm not going to actually stop this cluster because stopping it and restarting it takes multiple minutes. But I'm just going to simulate that situation. So here we have a cluster, Kubernetes cluster. This is actually AKS, but it doesn't matter. And you see that Dapr is installed, and we have all the pods that are part of the Dapr control plane, including operator and Sidecar Injector. Now, let's try and pretend that, let's scale down the Sidecar Injector. So we have 0 instances of that running. And we can see that here that Sidecar Injector is gone. This is obviously something that should never happen in a real world scenario, but I'm simulating the situation in which the cluster is restarted and the sidecar injector has not started up yet. So at this point, let's deploy an app. This could be your app restarting. And this app is just, it doesn't matter what app it is. The point is that this app is supposed to have a Dapr installed. And if I see here, the app is running, but when I look at the pod, you see the annotation dapr.io/enabled, but you also see that this only has one container, which is only Nginx, and it's missing the Dapr container. And let's say that then the cluster keeps restarting. So like the application restarted, now the sidecar injector is restarting. So I'm just scaling it back to 1. You see that the injector is starting. Let's wait. Okay, it's restarted, but my Nginx app, which is the app that I want to have Dapr as a sidecar, still has only one container. And if I describe it again, you see that it still only has Nginx and it's still missing Dapr. This is working as expected because the sidecar injector only responds when pods are being created. Like the operator sends a request to Kubernetes. Kubernetes then at that time invokes the sidecar injector. And if the sidecar injector doesn't respond because it's down or for whatever other reason, because it hasn't started yet, then the Kubernetes just goes ahead and deploys the application without the sidecar. And it never goes back. So how do we solve this? Well, we have made, like I said, this is experimental. It is disabled by default, so you have to manually go and enable it today. But we have made a change to the Dapr operator service and added this thing called the watchdog. To enable that, we need to change a variable in the Helm chart and set this value here, Dapr operator watch interval. And this is the interval, like how often the watchdog is running. What happens is that when you enable this, your operator service, and if you have multiple instances of that, it's the leader of the quote-unquote cluster of the operator services, periodically polls all the pods running on your Kubernetes cluster and checks if there is a pod that has the dapr.io/enabled annotation, so a pod that should have Dapr but does not have Dapr. And we can see that now it's running, and you can see that this already now has 2 containers. So if I look at the logs for the operator, there's a lot here. So you can see that the operator went through all the pods and it found that Dapr demo, this is my namespace, and the pod name Nginx something does not have the Dapr sidecar. So what happens is that the operator at this point kills the pod, completely killing the pod. Then Kubernetes notices that the pod is dead. It's like the pod crashed, and it's supposed to have the pod, so we'll restart it. And this time Kubernetes is sending another request to the injector, and the injector this time is up and running and says, okay, inject the Dapr sidecar. And now if we go back to describing the pod, you can see that in fact we do have 2 containers. We have both Nginx and we also have Dapr. Like I said, this is a new thing. It's currently disabled by default. Up with excuse me. You can set it up by enabling that in the Helm chart by enabling this watch interval. The value is a number, an interval, so it could be like 10 seconds, 2 minutes. The actual value depends on what makes most sense for you, which depends on your RTO, your recovery time objective, how many pods you have, and a few other factors that depend on your own situation. The default value is 0, which means it's disabled. There's also another value that is possible, which is once, which means that this will only do the polling once when the operator service is started or where a new leader is elected, and then it will not do it again until you restart the operator service. This should help, but there are still some situations that we need to smoothen out when you use it in once. So for 1.8, I actually would recommend sticking to an interval if you want to use this, this specific feature. And this is the end of the demo. So open for questions now.
That's excellent. Yes, if there are any questions on this, that's going to be very help with a lot of the reliability issues.
I guess one question is, what are the docs? They're coming. I need to write them. I'll write them today.
Right, docs, and we'll capture this, and also on the docs, we also there's a link to this little video, so this will be good. Okay, fantastic. Well, that's part of our 1.8 features coming up, which you'll see as part of our recap. And so thank you. That was really good, kind of going through the scenario and why it's important. So with that, then I will hand over to you, Paul, and we'll go to our next segment, which will be diving into the new binding quick starts. So Paul, would you like to take that away? Are you there, Paul?
Doesn't look like it.
Looks like he may have dropped. Yes.
It's okay. I can go if we want to.
Okay, so we'll dive into the binding quick starts then another time. Just to kind of point out though, the highlight is that if you go off and you go to the quick starts repo, we put a sort of new bindings quick starts inside there that show how a cron job can be used as an input binding to push records into a MySQL binding as an output binding. And so the combination of those two shows how to combine input and output bindings together, and just generally how to use the SDKs and the HTTP APIs. So go check it out, and we'll do a demo of that sometime in the future. But that's available there now to help sort of understand how to use the SDKs along with the bindings. So, okay, then we'll skip past that, and we'll move on to you, Nick, and talk about the AKS.
Oh wait, Paul's back.
Oh, okay, Paul. Are you there, Paul? Oh, he's back.
Sorry about that. I thought I'd be polite and show my video, but that was too much for my tethered internet to handle.
Okay.
And it took me down. There's an old saying, I guess, in marathons, and I've never run a marathon, but you're supposed to not change anything, not even your socks. Apparently, I changed something. So anyway, hey everybody, I'm going to go without video. I can still go, Mark. I have time.
Yes, you have 10. Yeah.
Okay.
If you leave a few minutes for Nick at the end, that would be good.
That sounds great. So everybody, Paul Yukonovich here, member and now maintainer for Quick Starts in STC, and happy to show you the new bindings Quick Start that we've been working on. It was originally contributed by Nir Mashowski, who's a new member, and then a few of us kind of helped get it prod ready and documented and up to snuff. The bindings is we're really, there's a bit of confusion between bindings and PubSub and some of the other APIs. The main is that bindings are really good to communicate with a whole host of external things. So for example, there's a number of inputs, which could be system events, it could be Twilio, it could be Twitter, could be Kubernetes events, just all kinds of external things that you want to respond to. Those would be an input binding or an input event. And then there's a number of APIs probably we control, like the sub book, I'll execute them. And that can be extremely handy. It's kind of like the ultimate escape hatch where you can work with existing code, existing systems. Eddie before talked about brownfield. We know there's a lot of brownfield out there. And so, bindings are super helpful in that case. So that said, let me show you what we've done. So if I start at the Dapr.io website.
Paul, just you're saying you're not sharing your
find
screen.
all the quick.
Oh, there we go.
Oh, it's not in yet.
Yes, your internet's a little slow.
I do apologize. I'm on an exhausted internet situation today. Long story, but it is what it is today. Okay, so I went to the Dapr website, click getting started. The quick starts are right here.
Yep.
Well, the screen hasn't been shared just yet, so you're kind of lagging behind there.
Yeah, you might have to just show.
Okay.
Well, now we're seeing it, but I think there's like a 30-second lag. So, well, I mean, let's try this out. Move your mouse down. No, okay, then yeah.
I think. All right, I think you've got to.
Yeah, I think there's too much of a lag there to basically share the screen. But for me, what I really like about this new quick start refactoring is that it really, as Paul said, shows the difference between bindings and pub/sub. And also it shows pretty clever combinations for how to receive events and then push those out to external systems, in that case, Postgres. So yeah, I really dig that example.
Yeah. Well,
hey, I'm back. Still there?
I think we're gonna just, you know, do that some other time when your internet's
Okay.
better.
Yeah.
Okay, no problem. Sorry about that. Yeah, my kids tethered off my Wi-Fi right at the wrong moment.
All right.
Yeah. Well, let's try and squeeze it in and come back another time for this. And we'll just move on to the AKS extension for now, if you can get the internet a bit better for next time. Okay, Nick, let's move on to you.
Yeah, do you mind sharing the one slide, Mark?
Yes, I will share this one slide.
Cool. So hopefully everyone can see that. And hey, everyone, start off by introducing myself for those that do not know me. My name is Nick Greenfield. I am a PM working for Microsoft and currently contributing to the Dapr project. I'm also one of the maintainers of the docs repo. And so today I just wanted to quickly touch on a new Dapr integration, which is the Dapr extension for AKS and Arc-enabled Kubernetes. So this extension, as of a month ago, has gone GA, or another term for that is stable. And so the purpose of this extension is to allow development teams to easily provision Dapr on an AKS cluster or Arc-enabled Kubernetes cluster without the need for any other Dapr specific tooling. It's you can use a simple single Azure CLI command. As you can see in this left screenshot here, just one command passing in your cluster, resource group, and the type of extension that you want to install, which in this case is Dapr. And so, and that will eventually, when that provisions, it will provision the Dapr control plane in the Dapr system namespace on your Kubernetes cluster. And so this extension also comes with a nice couple of bonus features. For one, you can opt into automatic upgrades of the Dapr control plane. And so what that means is when a new version of Dapr is available and you opted into auto upgrades, the extension will offload management of the Dapr runtime and upgrade that control plane on your behalf. It also comes with some production ready defaults. So as you can see in this right-hand screenshot, this is the kind of after the installation has just happened. You can see Dapr, the system namespace is there, and you have Dapr installed in high availability mode. Additionally, the extension supports all native Dapr configuration options just through simple command line arguments. And lastly, this version of Dapr offered through the extension is fully supported. So it follows the support policies of other Azure and AKS offerings. So for those that are running Dapr on AKS or exploring that option, I recommend checking out and using this extension. I have a couple of AKA links down at the bottom here. The top one is a deep dive into the extension and all the different configuration options that you're able to leverage. And then the other link is to some quick starts that will get you hands-on with the extension and deploying a sample app so you can actually get up and running with a Daprized app running in AKS or an Arc-enabled Kubernetes within 5 minutes. So would love to have folks check this out. And if you have any feedback, you can find me on Discord or on GitHub.
That's fabulous. Excellent. Yes, go and try that out. Okay, so with that, thank you. With that, we have perhaps a couple of minutes. If anyone has any particular burning question they'd like to post, ask anything else about any of the presenters today, or ask about or propose anything else that they'd like to have as a future session. I know there was a post that came out on the Discord channel yesterday asking about some, talk about workflow at some future sessions. So we're going to try and arrange that. So if there's any other questions that people would like to post while we have a couple of minutes, free to post them now or ask away. If not, then thank you for joining us today. The next community call will be in 2 weeks' time. It'll be on the 12th of July. And at that time, we will actually have a deep dive into the V1.8 release. So we'll do a recap of some of the features that we presented in last community calls. Jeroen showed the lock API in the call before last, and also the topic dead letter topics. In this call, we showed you the improvements to the Sidecar injector, and then we'll do a full recap at our next community call, or about 1.8. And by that time, hopefully 1.8 will be in your hands as in GA, as a stable release. So it's going to be an exciting time. So thank you for joining us today, and we'll see you in 2 weeks' time.
Thank you. Bye-bye.
Thanks, everyone. Hey, Mark, I was going to say I could try one more time for redemption, but if you want to go next time, that's fine.
We can do it next time, I think.
Okay. Yeah.
Bye-bye.
Okay, bye-bye.